Welcome to the 2024 MTS, the Media Technology Summit from SMPTE. This is an early session, so before we have all of the big introductions, we're going to get started with this, tutorial, the intro to production technologies and challenges. So I'll just hand it straight to David Long.
All right. Thanks, everybody. In the interest of time, we're going to get after this pretty quick. So again, these primer sessions are meant to be beneficial to attendees who hope to understand better some of the talks that follow later in the program. At the conclusion of this primer on virtual production technologies and challenges, we'll all dismiss out of here and go over to session room 1, where the keynote address and the introduction will be. So let's get after it so we can all be ready to get over there. So virtual production is clearly a technology trend that's of interest to many of us in the room. And I'm going to start introducing it by showing you an example of its results. So in 2021, at Rochester Institute of Technology, where I am a professor and I am director of Magic Spell Studios, we kicked off a proper and formal curriculum in virtual production in association with Epic Games. And the very, very first class was asked and tasked to do a complete virtual production project. So the piece I'm going to show here is a little bit dated, it's a little bit old, but it is the very first one that our students put together, and it's in an advertising format for the electric vehicle racing teams at RIT. So let's watch that. There we go. All right, so most properly, that was produced using techniques currently called on-set virtual production, or if you prefer, in-camera visual effects. But I'm a fan of a little bit broader definition. Effectively, virtual production is any integration of real-time computer graphics or CG workflows into traditional live-action filmmaking. And that can involve several departments, several steps along the production pipeline. But the common thread amongst all is you are bringing the CG work of traditional post-production and visual effects houses more so into pre-production and production itself. So we'll talk about a couple of peripheral techniques and technologies. The birth of virtual production prior to us deploying large screens on sound stages and sets to form replacement of blue and green screen components. The precursors to that were simple tracking technologies, pre-visualization technologies, embracing 3D software, 3D workflows to enable live-action filmmakers to explore creativity more effectively. And as it has progressed, we come to think of shots like this in the traditional sense. So this is from an exercise that RIT did in cooperation with Synapse Virtual Production in Los Angeles, actually just a couple of weeks ago. We've been taking our education on the road and been teaching industry professionals some of the tactics. So you see the real camera move. We're on a virtual volume, an LED volume, and camera choreography on Dolly was in the first sequence. And then you see the shot. I'm here photographing, obviously, the reference monitor on set. But the illusion pulls off pretty well, and you can pull off a driving plate shot like that with dynamics and, as we'll see in a little bit, with proper depth representation as well, which is part of the key. But again, there's associated technologies you often hear to virtual production, specifically things like visualization. These are not necessarily real-time, but they are increasingly taking advantage of real-time technologies. They were born using more traditional Maya, Blender, 3D graphics pipelines, but now the game engine renders, the real-time renders are much, much more popular. And the visualization techniques, using those tactics kind of come in different stages of production, all the way from pitching a project to pre-visualizing sequences. Very importantly, pre-visualizing technical execution, so how the production crew are going to pull off some complex shots with camera department equipment, and then can extend all the way into post-visualization as well. A couple of reels here very quick from our friends at the third floor. Chris Edwards at the third floor is a proud RIT alum, so we get to work with him a lot. And this is just a quick snippet of some of the stuff they do. Different levels of complexity here, too. So again, done in 3D software. Chris and his group over at the third floor are increasingly embracing real-time and using Unreal Engine in particular to do some of this work, but some of these sequences and segments come from a traditional 3D animation pipeline, too. And then Chris and his group over at third floor offer lots of technical visualization. So here you're going to actually try to block out camera department moves with specialty equipment, various cranes and gimbals, and also blocking of visual effect shots with the real talent. See some examples here. Other technologies that are critical for virtual production include the various performance capture technologies. And you all have a probably visual in your mind of what a performance capture technology entails, usually someone hanging out in a ping pong ball covered suit whose real locomotion, real kinetics are being captured by a bank of cameras surrounding them and being ingested into the computer. Of course, you can deploy that on all kinds of different movement tracking. You can put fine tracking markers on a face, and you can get animation performance and dialogue delivery. We think about examples years and years ago with James Cameron and Avatar in that. Full body capture to replace hand animation for different sequences and CG elements that need to make it into the final piece. But also doing tracking of camera choreography, camera movement too. So pre-visualization of kinetic camera activity, moving the camera around, having a DP actually frame shots, but those shots be tracked on a stage that's similarly able to figure out the location in three-dimensional space, put that into the computer and guide the virtual camera for the eventual rendering. And if you can provide immediate feedback of that activity to the creative team on set, then it qualifies as real time, and it again is a important part of the spectrum of things that we call virtual production. So again, this is what you probably expect. This is one of our students from a couple of weeks ago. We had a little competition, figure out who was walking. So we did 10 of the students, and just by looking at the animated dots, see if we could figure out who was who. So when you do performance capture, right, you can bring it into a virtual production in several different ways. You can pre-animate a synthetic character, an avatar character that the live actors need to interact with. That's what we're doing in these images with the production we did on campus a couple of years ago. You can also have someone who's performing off stage, off camera, and doing that live interaction. Again, for the talent, for the actors, SureBeats trying to interact with some poor stagehand who has to don a green or a blue lycra bodysuit and pretend to be the CG character that they're performing with. So to actually have that represented in a real-time visualization on something like an LED volume is super helpful going forward. So we're going to talk the rest of the time about on-set virtual production in particular and speak intentionally about the breakdown of the workflow. We often think of it in 3 different compartmentalized departments. You have the art department gone virtual. This is the same crew that dresses the set, dresses the actors, figures out what needs to go in front of camera to make the thing look good. They are now obviously doing their work in a 3D environment, so they're a virtual art department, or VAD. Similarly, they are then to hand off their content to a group called Volume Control, Brain Bar. It's gone by many names over the 5 or 6 years that this has been a hot trend. Volume Control seems to be a good generic one now. And that department is responsible for deploying virtual assets in such a way that they render up onto a series of screens erected on a soundstage that are in camera. They are actually in the shots, and they're there to be interactive elements for both the art, for the performers, and for the camera. And then finally, the last team, or the creative team, who are learning these days slightly new ways to light and some challenges involved with lighting. When you all of a sudden surround your talent with emitting screens, you've got some issues in color physics and color systems. You've got some issues in creative lighting limitations, and you've got some issues in shot selection. The screens are getting larger and larger. They are enveloping talent on these sound stages, but there are still borders. And there's cool tactics to do set extension to take care of that. but there are still limitations, and people who are pros will say they can tell a VP shot just because of some of those limitations. So some of our speakers this week are going to be discussing and addressing issues that are associated therein. We just want to think about continually making the processes easier, more accessible, more standardized, and better for achieving the eventual aesthetic intent that is that juxtaposition of a CG element and a real live actor. So again, from our experience a couple weeks ago, just some quick stills that let you see what life is like in those three departments. So the virtual art department is fundamentally responsible for asset generation, usually working in a game engine these days, Unreal or Unity, or working in a pre-rendered content that's going to be played back in a media server, Friends at Disguise and Pixera as good examples. And these folks are responsible, again, for dressing all of the virtual assets that need to be handed over to volume control to be played back real-time for the creative team doing the capture. And this might be an environment that makes it onto a stage. This is the Synapse virtual production stage at LA Center Studios here. And this cityscape was the topic, or was the backdrop, the environment for virtual production, short one we did a couple weeks ago back here over there at their place. Volume control involves all the complexities of a giant engineered system, right? So a lot of the talks and approaches to virtual production that are represented by friends of SMPTE and contributors are dealing with the tech layer at the back end. So virtual production wall is a massive array of emitting LED tiles that are driven by separate LED processors. If you want to think of it, it's kind of like taking a TV and ripping the processing guts out and placing it in a different tool. You do that so that you can literally show up at a location and assemble the tiles as just the emitters, and you rely on the LED processor to do all the addressing and mapping and serialization of the signal. So this is looking at the back of one of the wild walls at the Synapse virtual production stage. Gives you a sense of how it's constructed if you've never had the pleasure of being on site with one of these. Here's another shot that gives you another inputs to the complexity of this networking and signal routing. Increasingly, SMPTE 2110 is coming in favor to form the backbone for signal communication in these systems. So there will be some papers, I think, this week that are addressing that. There are certainly engineers at all of these major production companies that do VP who are working with 2110 specifically. Mission control, or the volume control, if you will. These are the operators that are dealing with driving the virtual art to the screen and also receiving input from various tracking mechanisms, because we'll talk in just a minute or two that you have to know where the camera is moving in the space for the parallax and the 3D effect in real time to work effectively. So that might be happening back here with a series of operators, engine operators as they might be called, watching along in communication with the DP and the camera crew. Also, this is the domain of the VP supervisor typically. This is the person who has their purview of the entire workflow and process live for the productions. And this is Emily, who is the VP supervisor at Synapse. She's working with a couple of the students in the class we taught a couple weeks ago. And just a view of their monitoring of the operation for mission control. And then ultimately, their job is to support the execution of those digital assets as they're viewed through the camera. So here we have the director and the DP who are in communication with volume control and talking about a couple of adjustments to lighting and exposure level they want to achieve. You do the same kind of stuff you do on a traditional set. You want to set up for framing appropriately. You want to make sure that any auxiliary lighting is doing the job it's supposed to. You can see here in the periphery of this picture, we are still bringing practical lights in. That's actually a big issue. We don't want to rely on the LED walls and the LED emitters to be the sole source of light. It causes all kinds of color troubles. And here's a wider shot of that same configuration. So again, you can see some traditional airy lights and camera and grip equipment in the scene that are augmenting what is the emitted graphics of the virtual art on the background of this particular volume. So back in 2021, SMPTE launched what we called Rapid Industry Solutions for on-set virtual production. I'm actually one of the co-chairs for the education group therein. And one of our outputs was a SMPTE flowchart that helped newcomers to the topic understand the departments, the responsibilities, the tasks, and the interconnections, and specifically the interconnections We have a second group who are on our efforts who are focused on interoperability, and some of those folks are speakers here this week, and we'll be talking about the latest and greatest of their investigation into interoperability. But you can imagine that when you are needing to bring a synthetic 3D world into a space where you've relied traditionally on actual constructed prop elements, and you've been on a soundstage with the traditional workflows for talent blocking, camera blocking, and lighting, that there is a lot of engineering that must be done to get those two worlds working together carefully. So this wall chart is actually in revision as we speak. The RIS OSVP team here at SMPTE are fabricating adjustments. It's a fast-moving world, and things have changed even since we published this. And the publication of this is also inspirational to working groups and experiments that members of this team are contributing to, and some of the other papers that are going to be presented at MTS this week. And I want to just go through a couple of them so you have a respect for what might seem easy is actually not. What might seem trivial is not at all. And in particular, there are some categories of complexity in the imaging chain we have to address with on-set virtual production. First of all, very simply, as my friend Rob Bogart at Epic says, it's all about color matching. When a virtual artist generates a 3D element on their workstation and it shows up on a big LED volume to be photographed by a cinema camera, you expect to look at the dailies from that cinema camera and see an exact match. And that might sound trivial and easy, but it's incredibly difficult because of the spectral energy distributions and the particular color science involved in real things illuminated by cinema lights versus fake things emitting off of a LED wall or an LED volume. And so camera to virtual art department color calibration is a big deal. I'm on a panel on Thursday where we're going to be addressing an article that we are writing for the SMPTE Journal in a couple of months where we talk about the basics, just do a treatise, a primer as well on that topic in greater detail. So you should look for that. That's going to address a lot of depth to what I'm just introducing quickly this morning. In particular, there are many elements of the virtual production color pipeline where you need to match foreground to background. So I chose this picture because in the synthetic world in the virtual art department, we have a crosswalk and a street that are synthetic, and they are supposed to transition somewhat naturally in color representation to the actual ground treatment that's on the surface of this soundstage floor. They're not going to be in a critical spot in camera necessarily, and you could probably pull off the illusion by hiding some things at the seam, but you do need to be extremely conscientious to color match there, and here's the rub. When you make a color with an emitting set of LEDs, you can fine-tune it using the theories of color science to get what we call a metameric match for a single observer. And it turns out that all of us are slightly different. It turns out that our cameras are slightly different. And there's not universal agreement to what that single observer is or should be because there is not consistency amongst all of us. It would be an impossible task, right? Some of the solutions to that task might involve introducing additional primaries or a more spectral rendering pipeline in our virtual art departments. However, LED lights are great. You can use a few of them. They can be very narrow spectral emitters, and you can make these massive ranges of color, which everybody loves, especially your CG artists. And then you turn around and point a camera at them, and they don't look like they're supposed to, because if the camera is not tuned to the average standard observer that we use in color science to represent human beings, and everything else is, then the camera is going to necessarily reflect an awkward and inaccurate rendition of that content. So this is a demonstration I did for my students a decade ago. Kodak, my former employer, had come out with this new Super 8 brochure, and I thought, that's fun, that's Kodak Yellow. There's a company that cares a lot about brand and color, like others. And I thought, okay, well, let's make a photograph of it, put it on my computer screen at the time. It was an Apple Cinema display, if you're curious. And I measured the spectra of that yellow in that picture on my computer screen. That was the green spiky spectra. And then I held up the actual thing, and I took another camera and I photographed it, another camera that was not me and not my vision. I had tuned the two of these just manually to try to make them match to my color vision as well as possible. I am also not the standard observer, but fun fact, I'm kind of close, which is useful for a color scientist. And I attempted to make that match visually for me. and then took my camera out and photographed, and I don't know how great the color pipeline is on this AV system. Not going to probably trust it versus a good calibrated cinema or broadcast system, but there's likely to your advantage a little bit of a difference there. So even though I was happy with the match visually, the camera that I used to take this picture is not getting it perfect. And imagine that is the VAD crosswalk and the fake road that are supposed to blend together seamlessly. So yes, we tuned it. It was brilliant to the DP who said that the match, the seam was invisible, and they turned on the camera, and unfortunately was not the case. But that's not the biggest problem. The biggest problem is when we don't bring in auxiliary lighting to illuminate talent. Turns out that the cinema lights are a distinct spectral emitter from the very narrow emitters of LED panels, and that causes a big issue with color rendition. So a lot of controversy on this one. Hey, virtual production, you have a room made of light. You don't need other lights. Well, let's illuminate a human being in a Macbeth chart and a human being wearing a Macbeth chart. Fun. And a random tie I had in my office. He's not dressed for that tie, but I wanted some piece of wardrobe because he showed up in a black shirt. I was appreciative of the Macbeth chart on it, but it was just a black shirt. So I threw my tie on there. So this is my current student, Aiden. He's brilliant. You should all hire him when he graduates in 2 years. We took a picture of Aiden illuminated by one of our LED volume panels on the left. And then we took a picture of him illuminated only by a ARRI Sky panel. And by the way, an ARRI Sky panel itself is an LED array that's attempting to mimic traditional continuous spectrum lighting. And you can see that we've got some problems. The neutral scale is matched really, really well, as was the intent, but we've got some saturation issues, some skin rendition issues, and that tie, well, RIT orange is probably a little closer to the left, but that's not a good conclusion because we're not supposed to light with LED panel. Other issues that we're trying to solve. Of course, LED panels are a big pixelated thing being photographed by a big pixelated thing. So here's an example. This is the Synapse stage, and I'm using a high-quality Nikon DSLR and photographing their very high-resolution LED panels, and I still, by the vantage and by the aliasing frequencies involved, was able to get a little bit of moire artifact. You shouldn't focus on LED walls because you might get that artifact, and engineers are constantly trying to mitigate that as best as possible. And then if you come to poor RIT, where we're not as well endowed as the investors at Synapse, and you look at our problems, they're a little bit worse, so we have to stand a little bit further away, and we have to make sure our wall is definitely out of focus. But this is a problem, right? This is a problem, and it's nobody's fault. This is sampling frequency interference. This is aliasing 101, and it's going to happen. You can't make it go away. Another thing that I like to show off, Flip Phillips is on our faculty. He was a part of the creation of this Pixar title you might recognize and know and love. Flip and I talk a lot about the problem of temporal aliasing or temporal sampling. Turns out that an LED volume, if you treat it like a big TV and you drive it at 24 frames per second, guess what doesn't blur in real contiguous time? Motion. You are freezing the motion in those frames, and you are taking a fixed duration photograph with a camera shutter. And unless you pre-render in motion blur, you don't get the effect. And a lot of people say, oh, who cares about motion blur? We're still going to pan the camera on our VP stages. That'll give some actual camera motion blur. The problem is you need the content to blur as well, which is computationally expensive in the render. So Flip likes to use this example because they intentionally chose a hypothetical 0-degree shutter, or if you will, a infinitesimal shutter duration to do the render of the first part of the sequence. And then they flip back to the more traditional rendering paradigm of about a 48th of a second, as would be standard in cinema for the second part. So just watch the distinction in the aesthetic, right? That matters. You see a very different temporal behavior to that render versus the smooth motion blur associated with this. This is not a VP shot, but it does give you a sense for, in synthetic images, you still care about shutter duration, you still care about that temporal aliasing. Another thing that's really important, another couple students in front of our wall, notice we got a little further back so we didn't alias it. Genlock, synchronizing, and they thought that was fun. There's a goofy falling sound that I chose not to share this morning. But we have to look at issues of genlocking your display with your capture device. Everyone who runs a VP stage knows you have to keep the entire system in synchronization, because if you don't, like we didn't on purpose here, You get the fun artifact of the double exposure, right? So the camera shutter time span is crossing over 2 refresh frames on the LED panels. And so you get that fun effect that's not intentional. You can fix that with Genlock systems. They're pretty complex, but they work fairly effectively. Another favorite of mine is depth of field conundrum. So this is the classic elementary definition of depth of field. You remember when you photograph something, traditional geometric optics, there's one infinitesimal object plane that generates one perfectly sharp, infinitesimally thin image plane. Put your sensor there for what you care to be focused on. And anything further or closer is going to establish what's known as a blur circle or circle of confusion. And we love it because that's how we get depth of field. However, we have to somehow generate what really happens in a beautiful photograph of a tree with a shallow depth of field in this thing, which is a end display rendering or camera vantage rendering of a 3D environment. So we have a rough model that is here viewed in 3D space, and that big black plane would be the mapped LED volume, and you are attempting to do a depth comparison so that you can render, amongst other things, the depth of field accurately, the camera angling, the frustum size. Frustum, by the way, is that angular field of view that a camera sees off into infinity space. And the struggle here is that this is a shot from the work we did a couple weeks ago, and the cinematographer, and actually it's me, I took the picture and I chose the depth of field. The cinematographer, chose to have a very shallow depth of field in the real art, and thus the wall is out of focus. Well, hopefully the camera is communicating back to the virtual art department the focus distance, and the render, the real-time render from Unreal Engine, is also imparting a blur, a depth of field blur appropriately too. Turns out that if you study computer graphics, we still don't really do depth of field simulation very accurately, especially in real time, because it's, again, computationally expensive, but it's possible. But the issue comes when you are photographing a LED volume that is a surrogate for a 3D space, and you put it in the blur of the depth of field, so it's out of focus, but you're also asking your poor game engine to predict the depth of field blur that should be there if it were a real 3D space as well. And so you can actually conflate the two depths of fields, which if you've got a good eye as a cinematographer, you look through the lens and you know that just ain't right. A couple of other things we're studying here with the Onset Virtual Production team, standardizing camera tracking. So again, if you're looking carefully at the wall behind, you see a rectangle that's kind of moving in Vantage. That's the inner frustum of a virtual production. That is representing what the camera's pointed at. So there are several different tracking technologies from Stipe and Mosys and NCAM and others. And having everyone use the same language and communicate from stage to engine the same way or stage to media server the same way is a big concern of us here on the RIS OSVP. And then finally, so too are all these fabulous camera and lens metadata fields. These are the things that causes a camera to do what it does. Lenses are not perfect. They have distortions that vary with depth. We want to get that into the rendered world appropriately. So we have to figure out a way to translate these actual camera settings and lens settings into the virtual environment so that when you construct the frustums in that space, they are as optically accurate to the real thing as possible. And you see an example on the right where a DP might be pulling off a very specific depth of field and want lenses with a specific distortion. So hopefully, all in all, that helps you guys keep track when you attend some of the other talks this week on virtual production, lightning fast, and just in time for us to all get up and move as a herd over to the keynote introduction. Thank you.